Okay, so today, folks, this video is hopefully giving you a good heads up on how to cope with exponentials, as in, how do you differentiate an exponential? For example, this is what you'll be doing, and if the original function is f of x equals ex minus 2, the derivative function, interesting enough, looks like it's the same thing, hence the expression of awe and wonder by this chap here. What you're seeing here is the formula sheet. And if you were to, I've placed the formula sheets on the intro section here, click in here, click on that. It'll take you here, second page, this table here. So the first column is the function. Okay, let's say f of x is equal to ea of x, and next to it is your derivative function. Now this one here is a bit more complicated. It's got a, and it would appear that the coding is, if you've got e to the power of ax, the first derivative function is simply aeax. Okay, what does that mean? Let's just put this on a piece of paper and give you an example there. So the coding was, if you had f of x is equal to eax, for example, let's say I don't know, 3x. Oops, you can see that now. Okay, so f dashed of x, the code is the a comes down, eax, and this example here, the derivative function would be 3e3x. Okay, so you're not subtracting anything off the x. You're not changing that number. So just that is technically what has just happened. Okay. If I just had, here's the key interesting thing. If I had f of x is just simply e of x, f dashed of x, so technically that's a 1 there. You can sort of see a 1. So there's the answer. So the original function, if it's an exponential, its derivative is an exponential. Wow. Okay, so let's put this into context. Let's put this in terms of a graph. Hey, in fact, what I should really have asked probably at the start here is, what is an exponential function? Okay, were you taught this in year 12 maths? So here's something prearranged. Take this off, take this off. Let's say you've got a simple y equals 2 to the power of x. That's the curve there. So when x is 0, 2 to the power of 0 is 1. Agreed? Yep. When x is 2, that value should be 4, as in 2 squared. When x is 4, it would be 2 to the power of 4 would be 16 there. Okay, so that is an exponential. Well, you could say it's 2. Yeah, it's showing exponential growth. Okay, if we locked in 3 to the power of x, it's the red. No, it's the purple curve there. Still, they share a common point here. When x is 0, anything to the power of 0 is 1. Okay, so here it should be steeper, because when x is 1, it should be 3. Hang on, there we go. When x is 2, it should be 9. And when x is 3, 3 cubed is 27. Okay, and obviously we can see x equals 4. Now, this thing here, if you type in e on Desmos, for example, this one here, if I just put y equals e power x, okay, and that's what the curve looks like. Turn it on. Okay, take these other ones off. And so you can argue the exponential curve sits between the 2 and the 3 there. Just give it a different color. Let's go for yellow. Yeah, see, right, so obviously it's similar to the 3 power of x, but it's not. Now, technically, here, I just typed in e, and it gave me e to be 2.7182818, and it's not repeating. So if we go back to our notes here, this is a slide capture from Tahi Maths, really good. And obviously, it's a very important number. It appears quite a lot in maths, and we attribute it to this person here, Euler. And I guess that's where the E comes from, his first letter of his surname. But here's the code. It is a unique number. It's irrational. It's not repeating. So the function equals AEX. Okay, then guess what? The derivative function is the same. Okay, and this bit here is a bit of chain rule. If you understand the chain rule in this context, you'll understand that coding there. Right, so if I were to try and graphically show this to you, probably pretty poorly. I don't have haven't done it on Desmos yet, but okay, here we go. There's your exponential. So let's say this is y equals EX. Okay. No, let's just call it f of x, because that's the notation I want to get you very comfortable with. So if we plug in here, okay, at 0, so let's say f of 0, and that's going to be e to the power of 0, which is 1. Okay, now if you got a different colored pen, no, what pen is this? Oh, okay, yep, if I went here and drew the tangent at x equals 0, guess what it's going to be? It's going to be 1. So the gradient of this red line is 1. Now, if we go to 1, okay, go to 1. Okay, so f of 1 is e to the power of 1 is 2.718 da 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 da. Okay, now if I were to work out the tangent gradient at, if I said f dashed of 1, pen's dying, okay, that there, the steepness of that tangent would be dot dot dot. Okay, so did you get it? Basically, the gradient function is the same as the normal function. So that is the cool thing. That is the key feature that you need to get your head around for these things here. Okay, back to here. Right, how to learn this. Please do. This here is a bit technical, to be honest. This assumes you know what first principles are. Yeah, I'll put that in a comment afterwards. But what do I mean for first principles? We sort of skipped it in the Wednesday VC sessions. Differentiation by first principles. If you're interested, go look at it. If you're not, don't stress. We've got enough things to keep us busy. Okay, do learn this. Yeah, okay, so there's read pages 95, 96. Tahi Mass is pretty good. Here are some examples of applying this technique to differentiating exponentials from Mr. Chanda, Infinity Plus One. What's this say? Obviously, we're still under basic rules. There's the category number 4. Practice these questions. I've got here 6 questions for you. And as it says here, take a picture. And lastly, yeah, feedback, and you get the joke here. So this looks like some sort of Disney character, and Hercules. Okay, so he's about to slay this monster, and bad news for Hercules here. It somehow turns into a 3-headed monster. So what's going on there? So if we were to, yeah, what's the meme trying to tell us? Basically, this is what's happening. Let's assume the meme is saying f of x equals e3x. So technically, maybe he's the function or whatever, but yeah. Okay, so we've got a 3 up here, and the rule is, okay, there's the rule there. E3x, oh, there we go, E3x, differentiate that. The 3x bit doesn't change, but the 3 does come down. Okay, so f dashed of x equals 3e3x. So what's that saying? It's 3 lots of e3x. So I guess 3 monsters. I guess that's the joke there. Yeah. Okay. So do look at these solutions here, and obviously STEM Online has some some other examples and some drag and drop, and some sort of gives you feedback. And once you're confident, I think you'll be away. And hopefully, yeah, this selection of questions here can help you use them. But yeah, do have a go at some problems. Do a selection. One's probably not a selection. 4 or 5 from that page. If you're confident, boom. You could say, look, at the end of that page, can I do the questions at the end? If you can, you're sweet. If you're not so confident, start at the top and select your way down. And obviously, if you're really stuck on something, you've checked the answers, make a note of it, flick me an email, and that'll be hopefully some feedback in the week, or most likely, if you've emailed in, I'll say, right, someone's requested number 117. Here it is. Okay.